Welcome to the PGN Podcast. With this podcast, we're looking to normalize the conversation around flooding. What happens behind the scenes, lifting the curtains on the mystery that can sometimes come into play when you're either involved with flooding or trying to protect your home. We're talking to some experts in the industry and relaying some of the experiences we heard from some communities. Hopefully, after our series, you'll have a bit more information to help yourself or help others in an emergency where flooding is involved.
River flooding, surface water flooding and sewer flooding are more commonly discussed and understood. There is another source of flooding which, obviously is important to this project, so that's why we're going to do a bit of a deeper dive on it today. So that's groundwater flooding. Within the region, we are getting more and more groundwater issues. The region's been built on the success of coal mining, and a lot of people are here because our parents or grandparents worked in mining, and this is an episode obviously very personal to me too, but would like to dive into why that has such an impact on our groundwater and potential flood risks.
I'm Meshi, that's Carl, and today we're joined by special connection, Carl's dad, also known as Paul Hodgson. So it's a planning engineer with over 35 years in rail, water and mining, a project manager and mineral surveyor. So quite an impressive CV, and also a long-standing member of the Institute of Mining Engineers. Welcome, Paul.
Yeah, it's good to be here. Thank you.
We also have Rhiannon Marchi-Smith. So Rhiannon is our resident hydrogeologist. So she'll be filling in us on the ins and outs about groundwater and the particular relationships in the Northeast. And Rhiannon has had the pleasure of working both client side and consultant side. So she has a lot of different points of views and perspectives that hopefully will lend itself to this conversation today. So welcome to you both. Let's jump right in. What is groundwater and groundwater flood risk, Rhiannon?
So the most important question, what is groundwater? So at the basic level, generally speaking, groundwater is simply water that's present beneath the surface within pore spaces and fractures of rock. And what's interesting about the Northeast, and that's unique to areas such as around here, is the presence of mine workings. So they provide additional pathways for water to travel.
Why is that such an issue for us now?
So it's an issue now. So I guess we've got 2 points. Mm-hmm. What is groundwater flood risk? And then why has it become such a pertinent issue? Mm-hmm. So groundwater flood risk is defined by basically the groundwater level being too high, which can occur from a combination of it already being naturally quite a high water level and then intense and often prolonged storms. So that causes a possibility for groundwater flooding. So, the key question, why is that relevant now? With climate change and obviously increasing intense storms, it's becoming a lot more pertinent to be able to look and understand what the impact is on that, on water levels and the consequential flood risk.
Carl, you touched on the kind of legacy. The coal mining industry in the Northeast was a very successful industry for a very long time. And we've touched on this relationship with groundwater flood risk, but it would be good for our viewers, our listeners, to just get a bit more understanding on what that is. So just take us back to the basics.
Now, I was a third generation miner. My father was a mine surveyor. My grandfather was a colliery overman. So I'm a third generation miner. So I tend to dwell and emphasize the fact that three generations of mining in the Northeast coalfield has left quite a legacy. And I'll class it in two separate groups. One is we have left a man-made aquifer in the form of flooded mine workings. But in addition to that physical presence of waterlogged mine workings, we've also left a wealth of information in detailed mine plans. It's got borehole records, it's got lab analysis records, not just of core samples, and the consistency of the rock. We've also got lots of samples of the composition of the mine water that we encountered. And believe it or not, all the surveyors' notebooks, including my notebooks, when you finished your notebook, it was sealed almost and deposited at the Mines Record Office. So I cannot stress how much information is available to the engineers and geologists of today who are looking to control and take the benefits of heat from mine workings. There's a wealth of information there that I don't think people appreciate and understand. And I think if that information was referred to more, it would help guide and mean that any future schemes could be more beneficial, more cost effective. The caveat, of course, is that the mining legislation relating to the recording of mine workings, prior to 1872, there was very few potential mining records kept. But from 1887 to about 1896, the government at the time stressed the need that all underground mine workings should be surveyed, and abandonment plans had to be submitted and recorded somewhere. In 1911, that was when the legislation became much stronger. All underground workings had to be correlated and coordinated with surface features, for example. And whereas before there was no need to show levels of the different seams, that all had to be included on the standard mine plans. So that was in 1911, and it was like 2 years after that when the UK coal industry was at its peak, and at that time there was 3,000 mines, and we produced in 2019, believe it or not, 287 million tonnes of coal. So I say all this just to stress the importance of the mine record available is there, but prior to kind of 1911, there would have been a lot of uncharted mine workings. The other thing to mention, even if the coal mines were operating today, it's part of the Coal Mines Act that a surveyor has to be appointed to the mine. And if, for whatever reason, there is no surveyor in place for 28 days, that mine has to cease production. So you can have all the miners, all the engineers in the world. If you haven't got a surveyor plotting and tracking and recording where the minings are, that mine has to cease. So I just say that to give you a flavour of the importance of the records that are available.
I think the records is a really good point, though, because I think we obviously, as part of this project, work closely with the Coal Authority.
Yeah.
And part of the project is still gathering new information. So we recognize that there's still mining villages, that have a lot of passed down knowledge, which is of value to the project.
Yeah.
But it'll be good to understand from a scale point of view what percentage of some of those mine workings are uncharted or unrecorded as well.
Yeah.
Is there an understanding of what that figure is likely to be?
I couldn't say. I mean, what one thing I can say, in 1973, which is not a long time ago, there was the Lofthouse mining disaster. And you won't be aware of it, but there was a coal face advancing towards what was shown on the old mine plans, an old shaft. And the thinking was, looking at all the records, the surveyor looked at the records, that mine shaft only goes down. It's the bottom of that mine shaft, 70 metres above where the coal face is going to be. So the coal face carried on its extraction and advancing. And there was 7 men killed due to an inrush of water from that old mine shaft. And the subsequent inquest thereafter, they did more research through the records, and they found evidence that showed that mine shaft was a lot deeper than originally thought. And that resulted in stricter. It was 1973 saw the introduction of proportion against inrushes regulations, which basically meant if you were going to a potential hazard, if you were advancing towards a potential hazard, you had to do proving boreholes, just to prove or disprove. And if there was any doubt, you used to have to inject under pressure grout to do cementation of the strata around that potential hazard.
Yeah. I mean, from modern reference point, fairly modern reference point, I remember when the A1 made the news, when a massive sinkhole.
That was 2016.
So again, fairly recent. And I think we keep seeing, particularly around the Northeast, we keep seeing evidence of...
Yeah, I think, kind of from a local authority, from a flood investigation perspective, I want to refer back to an incident that happened in 2016. So that was an incident where there was water issuing in Swalwell at Derwenthoff, and water was coming out at quite a fast discharge rate on a dry day. And for me, investigating flooding incidents, I'm of the concept that water flows downhill. And it turned out that the reason the water was coming out of here was because there was an old adit, so a horizontal access into mine workings, an adit behind IKEA and Derwenthoff. Water was coming out of there, and the reason, following investigation, was the fact that the Coal Authority's pumping station in Kibblesworth was basically in need of repair. And what we, for me as a flooding engineer and understanding from a hydraulic perspective is, firstly, that is in two different river catchments. How does water get from the Team Valley catchment to the Derwent catchment? And how important is the positive pumping, and why was that brought in? But also, how deep did that allow people to mine? How we've basically had an artificial water table for so long because of the industrial heritage.
Yeah.
It's gradually increasing, and between that and when it returns, we've urbanized. So that water is going to issue at different places. There'll have been houses built on areas where things have issued, but also mine workings will create new pathways for the water. So in essence, if you could talk a bit about how we are where we are with relation to that incident, for example.
Yeah, well, there's 2 points I would like to make there, and it's going back to an earlier comment about the accuracy and the likelihood that mine workings are uncharted. If you look at the figures I quoted there, you've got to remember that centuries ago, when coal mining first started in the northeast coalfield, it was the shallower seams to the west of the county that were the first to be exploited, because many of those seams outcropped at the surface.
So where geographically was that one? Any towns?
Well, yeah, I would say west of Team Valley, basically.
Right, yeah. Uh-huh.
And you've got to remember also that there's about a third of the northeast coalfield that is overlain by Permian strata. So it was only in the early 20th century, I would say, when those deeper seams, deeper shafts were sunk through water-bearing Permian strata. And by then, of course, a lot stricter rules and regulations were in place for the surveying and chartering old mine workings. But the other thing to remember is that there's probably 7 or 8 workable coal seams within the northeast coalfield, and so if you mine the top busty seam, and then 30 or 40 metres below you've got the bottom busty seam. What you've got to remember is that those seams, even if they just work from the same mine, the same colliery, there will be breaks in the strata, there'll be fault planes, there might be stapple shafts sunk between the two seams,
Right.
So the water in one seam will migrate to another seam.
Is that down but up through pressure as well?
Yes. But
So-
the other thing to remember is, and I can quote you this, when I was doing my apprenticeship with Unsworth Colliery, we were working the Busty seam from Unsworth, and 70 metres above, Bolden Colliery was mining the Harvey seam, and we were getting inundated with their water. So mines and coal seams are interconnected. I always think that the whole of the coal field is one big sump full of water. And they're interconnected, sometimes by design.
Yeah.
I mean, going back to the outbreak of the Second World War, all the mines within the North Durham coalfield, I know were all interconnected because there had to be a second means of egress in case a shaft was bombed and the men were trapped underground. They had to have a second means of egress. So there was like tunnels and roadways linking all the collieries. So they're all interlinked.
Yeah.
I think Rhiannon's dying to say something.
No, it's just all I was wanting to say, I think, is just how it gets defined. And I guess this is sort of coal authority head.
Yeah.
So you have the different kind of connections
Yeah.
where you've kind of got your minor connections and your major ones. So
Yeah.
you're right that you can probably safely assume that at least in this area, because in the project we've got two, and we're looking kind of at the Berwick area, which is quite isolated.
Yeah.
And then
North Durham.
basically the North Durham coalfield, that is pretty much entirely connected west to east. But yeah, it's the different kind of connections where you've got the roadway connection where you're like, okay, looking at the water level, you know that's probably, depending what it is, it's directly connected and free flowing. And then you've got, I guess, ones that might be a bit more accidental or where they've driven into a fault. And if they've driven into a fault, obviously that's providing a new pathway and the water can move laterally. So I guess like the issue they've got, in the block south of the Buttonall Fault, where they've got the plume that's moving, and they drove through into west of Weir through the fault, and there's a roadway through there. But I guess where you've got the plume moving across the fault also can facilitate that flow. And then you've got, I guess, what they call narrow barriers or gove connections. So they probably are all connected, even if it's a narrow barrier. And then you've got your vertical ones, which are considered minor, but between seams, you're going to get some connection coming through on the borehole.
But that's the point right there. So when you describe groundwater, you're like, oh, the water can rise, and that's again assuming it's all homogeneous and everything else. And then you factor in shallow mine workings, and then the interaction between workings, and then fault lines, and you then have this quite complex, changeable,
and then there's
dynamic.
There's also the point that Paul made before that we've looked at, particularly to the west. So you mentioned about Kibblesworth.
Yeah.
And Kibblesworth is pumping, if we think of it largely as a sump across the whole area. It all goes to Kibblesworth at the moment, that's pumping it out. But that's largely pumping the deeper coal seams, because we assume some of the shallower ones are perched and not actually connected to those deeper ones. So I guess part of what we want to understand that we don't fully know is how that's connected.
Yeah, so by perched groundwater, for the listeners, could you please elaborate on perched groundwater?
So in general terms, perched groundwater is, so we usually look at it in shallow, superficial deposits. So what's come over the past, how long? Like 10,000 years since glacial period. And you might get clay lenses within that, so they're impermeable and you're just getting groundwater sitting on it. So it's not really connected through, and then you'll have the general water table below. Within the mine workings, it's because you might have shallower workings that are water bearing, but it's not connected vertically to the deeper workings, which, as I said, in the case of Kibblesworth, it's pumping there, but that pumping has no effect on the shallower water level.
So it's not very simple. It's not draining down. So what happens to perch water? If it doesn't drain down, what happens to it?
So it'll still discharge. So like to the west, we think a lot of that might be discharging out into the Derwent, where you've got Clockburn Drift and
Yeah,
around
yeah,
there.
yeah.
So I think that's probably a perched system, unaffected by the deeper pumping. And I guess that's sort of why. So with drilling and looking at water levels at Wickham Forns, that's one of the examples why we want to understand that perched water there.
So when we're talking about Clockburn Drift, that's Winleighton Mill in essence.
Yes.
Winleighton Mill is a lot closer to Derwenthoff than Kibblesworth is.
Exactly.
But they're not interconnected.
So is Derwenthoff related to the perched water instead of the deeper water, so it's not controlled by Kibblesworth?
Uh-huh. So I think that's really interesting because, again, while I've said I've looked at topography, I also consider geography as well when we do these investigations. Yeah. And again, the fact of perched groundwater against those deeper mine workings. So how do we know how deep Kibblesworth is pumping from?
Oh, it's a good question.
Put you on the spot.
I can't remember off the top of my head.
No.
I don't know.
You don't know.
That's
fair
really bad,
fair
isn't
enough.
it?
No, that's fine. That's fine. No, but I think, obviously, in essence, it was pumped to allow safe working of miners and to extract coal. And that's quite critical in the growth of our region. Yeah.
And I think a couple of good points have been made, which do link. So in this particular area around Gateshead where we're studying, obviously a lot of it is exposed coal fields. So the aquifer, the magnesium limestone, is over to the east around sort of Sunderland area. So here's completely exposed. And I think looking at things like when you were mentioning about the A1, there's a lot of questions around, obviously, the built environment and the impact that has on groundwater levels. So like you say, from your kind of LLFA hat, you look at it from kind of high to low in terms of topography, I guess, from hydrogeologist hat, looks at it from high to low pressure.
Yeah.
So you're looking at the changing pressure. So obviously when you've got things like the A1 or housing developments or any kind of design, if you're grouting in there, you're going to change the pressure regime and that water might be pushed upwards elsewhere.
Yeah.
So you change the dynamics essentially.
Yes. Mm-hmm. Yeah, and I know looking at schemes in the past, particularly on the Tyne River bank tidal floodplain, as you would call it, looking at potentially doing boreholes there for other schemes, there was a risk of borehole would become artesian.
Yeah.
So do you want to explain what artesian means?
Artesian essentially means sort of water going from high to low pressure. So so we look at groundwater in terms of pressure, and it has a pressure head, which is defined as the elevation. So that water level, so to say, is maybe above the ground surface. So if you drill a borehole into that location, obviously it's been pressurized maybe by an impermeable layer below the surface. You drill into that water level is going to try and reach its technical term, sort of potentiometric surface, but its potential level it wants to reach, so it'll become artesian.
Yeah. It's kind of like a geisha effect.
Yes, exactly.
Right. I witnessed that when we were doing shaft sinking on the Selby coalfield, where we drilled a series of boreholes around where the shaft excavation was going to be. And as soon as we drilled the holes, the water was just coming up like a fountain.
Just drilling some pilot holes around it.
I think we've kind of jumped into the kind of bit about urbanization with built environment, though, because I guess that's where we are now. Both Paul and Rhiannon mentioned the fact that the kind of era of the mining and the era now is we're living in a much more infrastructure-based environment, built environment, roads, buildings, the lots, and you talk about exposed areas as well, and all these things are all coming together in a space where we're worrying about climate change and the impacts of climate change, which we're seeing right now. And I guess it comes back to why now, why is it so important? Because for the most part, it's been out of sight, out of mind. So unless you worked in the industry, in the sector, so working for the Coal Authority, for example, being part of the community or the professionals that help to manage and keep the water superficially contained.
Yeah.
Now it's entering the public realm because we're seeing these events like in 2016.
Yeah.
We also know that actually to an extent, it will be influencing how effective some of the other flood management schemes would be. If you can't account for groundwater, then really whatever you're doing is compromised to an extent, because it will be taken away from the potential benefit. And one of the challenges of the project is to be able to create a comprehensive database to allow that clarity or better visibility of what the risks are, but also the likely areas of impact. I know you talked to us a little bit more about what that is, Rhiannon.
So, yeah, I guess it's, in general, it's really interesting, is it? Because it's one of the, so hydrogeology in general tends to look specifically at your more general aquifers. Look at a chalk-based aquifer or limestone or something like that. And I guess the problem in the industry is they sort of sit quite separately. So the really great thing about and unique thing about this project is the fact that it's one, probably, I don't want to say the first, but it's definitely one of the first to really bring that intersection between the built environment and civil engineering flood risk with mining and also geology in general. Because there's so much, like, we're trying to understand it. And as Paul said, there's so much information there. Well, that's where I guess it's a side note, but I think it's where technology and data management and also AI and things like that probably can help us a bit more with the amount of information that is there that we don't have the people to get through, that we might be able to start looking at those options.
Yeah, so mapping, monitoring, forecasting, warning, in essence, that flow path of data.
Absolutely.
Yeah, and again, I think what's important here is making sure that we aren't thinking in silos. As risk management authorities, we need to work with different authorities better and closer to come up with different solutions. And with groundwater, it's people like the coal authority, it's hydrogeologists, and then ultimately changing how that behaves if or when it gets to the surface, or if it gets to the surface.
But also I think groundwater has largely been kind of left out in the wild a little bit.
It is, yes.
So unless you're like working with a coal authority, and for the first time I would say that it's joining the other flooding siblings. And when we talk about integrated flood management, in order to be truly integrated, we have to have groundwater flood risk as part of a significant part of the conversation as well.
This is absolutely an issue. And sort of, as I said, where there's been so much focus on your kind of general, I can say greenfield, but it just means kind of more rural aquifers. It's always been through the scope of a lot, particularly in the UK, it's always through the scope more of water resources and environmental management. So hydrogeology in the UK, I think in general, I don't want to say poor, maybe that's a bit harsh, but groundwater has been a bit left off the Flood Water Management Act. Who's responsible for it? What do you do with it? And particularly with mine water, that just adds a whole other dimension. Having that opportunity to have so many people, so many different partners to actually sit in the room and be like, groundwater is becoming increasingly a problem. We know that we're getting more increased rainfall. We know there are changes. We know how the coal authority is operating now, particularly with sort of energy transition. They can't keep pumping as they are forever. Multifaceted issues.
And I think as well, we'll go back to urbanisation there. And there's still a need to build houses. There's still a need to grow our urban areas. And, as we as the lead local flood authorities have to do, we have to look at sustainable ways to manage water. So we're getting a lot more basins, and different parts of the country, for example, use infiltration a lot more to infiltrate that water down.
It's very one lane, that. I think with groundwater and the mining interaction, we've talked about energy opportunities. It's about the opportunity, and it's probably changing the opportunity to change a problem into a resource. So these underground networks, man-made underground networks, we were talking about limits with the existing drainage systems that we have because of urbanizations. And yet we have these networks that have been there for God knows how long, which are just essentially acting as passageways Can we optimize those? Can we formalize those assets? Can they actually become an opportunity for us to help either provide storage? Can there be?
Are we sitting over the world's biggest attenuation tank?
Exactly, that's the question.
100%. It's how to turn what is currently a liability into an asset at the heart of it. And obviously, part of what we're doing is we want to build a model of the Northeast coalfield and the geology to better understand it. But the big part of that is because there are so many dynamics at play with the urban environment, working with Northumbrian Water, then the coal workings and the geology. And then we think that because historically, way back when, 300 million years ago, it was a delta across the area. So there are buried channels and we don't fully know the full location because they're discontinuous, where there are sand bodies that also might be moving water or moving it into the workings. So to try and better understand that and put it into a model, I guess that's where we can start testing it and testing the sensitivity and around sort of the evidence and decision making to put that forward, whether that's around pumping and testing the re-injection, the effects of that when it comes to mine heat schemes. So obviously Gateshead Council has the mine heat scheme already operational in council buildings and with some of the local businesses. So how can we use that and also look to other areas that already have heat schemes or facilities to basically test the idea on, does it make it more cost effective to be able to pump? You're able to sell heat and energy, but also manage flood risk from it.
But it costs the pump. So
offset the cost. Can you do that with heating and energy and also control flooding?
But again, it costs to pump anyways, because that's what the scenario right now is, that a lot of money and a lot of energy is being spent to officially manage groundwater levels. And there's a question of how long can that last? How long is that affordable? And what happens when it stops?
Is it sustainable? And when it's cut out, what do we do? Yeah.
And one of the things I think what Rhiannon is describing there with the mapping and the modelling is, like Carl would say, modelling 101, the first scenario you do is do nothing. And I think with more information and something that you can at least reference a skill from, there is an opportunity there for us to actually check the scenario. We can be like, what happens if all those pumps stop working? What could that look like?
Or if they have to be turned off.
If they have to be turned off, what could that look like? And that could be your first step towards evidence towards something bigger, which is targeted.
If we knew then what we know now, and that is we've got a legacy underneath our feet with potential. If we'd realised that then, would the whole process and procedures for abandoning mine workings be different? And I'm seeing that in the knowledge that I know that most of the shafts were filled, and they were filled with the demolition discards from the surface buildings. They just knocked the buildings down and down the shaft it went. Some of the shafts were used to dump colliery waste, slurry from coal preparation plants. So some of that water would be contaminated with colliery waste. You know, I just wonder if we would have taken a different view.
That's a really interesting point. And I'm thinking of it from, I guess, a more current point of view as well, where you have current operational mining.
Yeah.
The future options around that, where obviously they have quite, particularly now because of various regulations around the world, they have such strict closure procedures that have to pretty much be done before they even put anything in the ground. But it's obviously beneficial to them, but what if that can be incorporated as well, if you're looking at sort of heat benefits and when it comes to pumping for mine planning in the present or future, looking at those options, because either way, you're going to leave some kind of legacy.
But the mine workings were planned in such a way to minimise the ingress of water. Mm-hmm. And also they were planned in such a way, in the event of us getting inrushes of water, that it was controlled. So purpose-built mine water standage tunnels were driven at certain locations where we thought, now for me, if we're looking at heat from mine water schemes, they would be the areas that I would be wanting to target with the borehole. They were generally, these mine water standards were a low point in the seam, and all the water would migrate there, and they'd have huge pumping arrangements set up there to pump the water to the surface. Yeah, so there's all that kind of information would be available on a standard mine plan, abandonment plan, of course, you know.
I think looking at the particular characteristics that we have here, the urbanization and the interaction with mine workings, there are other regions in England that could benefit from what we're doing here, aren't they?
The British Geological Survey have a facility in Glasgow that's been drilled into the workings there. So that one's fully recovered, so the mine water isn't rising. But when I was saying about testing in mine water, that facility has been created specifically for these kind of purposes, so we can go use it. But similar kind of geology, you're just looking at sort of coal measures geology, interworked coal seams. Then you've got other areas such as, so go back a bit. So there's a project in the Netherlands. I don't know if you know of it, Helle, I think it's called. And they have the mine water project. They work closely with obviously Glasgow. They also work with Nottingham Council, for what I understand. So they have quite a successful scheme. I can't remember what year they started, but they've been going, I don't know, maybe late 2000s. So it's been going quite well. They have quite a successful scheme extracting mine heat for district energy. And that's obviously two examples. So the other example is close to my heart, because obviously I'm from that part of the country, but there's also the Northwest as well. Yeah. If you look, I guess, closer to sort of around Manchester or anything like that, they've still got mine water discharges going into the canal and things like that. So what are the options if we're looking over towards kind of the Wigan coalfield or the Northwest?
It was quite a productive field. That Goldthorpe Colliery was near Lee.
It's going back to what you said about the legacy. We're living in a legacy, and I think part of our responsibility, our duty, is to ensure that legacy, because there's a regional pride when it comes to the mining industry, particularly in the Northeast. I think people talk about it with fondness. You don't have to go very far to hear about somebody. I mean, Carl, we're talking about Carl going down. You want to share that story in a bit, but you don't have to go far to hear about people and their parents and their grandparents and the stories around those communities. So I think it's something of pride. But then we have a challenge. We have a climate change challenge. We have a challenge for the future. We have a challenge to ensure that we can sustain what's coming us in the future. And part of that is taking this pride, but also hopefully with this project, securing that legacy. And part of it is probably looking at the opportunities of what we've inherited and how that can take us into the future. So I think that's one of the things for us, really.
Yeah.
But I was going to ask you, though, because I said I was going to ask. I'm going to ask. Because I think when Carl, because obviously I moved to the region about 12 years ago. So a lot of my knowledge around mining is what I've heard from colleagues, from friends, from people that live in mining villages. So I'm pretty much a kind of a sponge. I'm just absorbing it as we go. And I think, Carl, you mentioned about the fact that some of the mine workings, and you mentioned it, Paul, about the useless escape routes during the war and everything else. Were all those mapped? Like, we have records of all those?
Well, there is the coal mines records. I think that they're held by the Coal Authority now. Yeah. But each colliery, in accordance with the Coal Mine Act, used to have in place a standard mine plan. And they plotted all the workings at a scale of 1 2,500. And they were in 2 kilometres by 1 kilometre. So everything was recorded on the standard mine plan. And these were on what we call pagra sheets, that were almost like cardboard. and they had to be kept in a fireproof safe.
Wow.
And those mine had to be updated every 3 months, or if any working advanced more than 100 metres, it had to be surveyed and recorded. So that was the main mine plan. But on top of that, there was a whole suite of other plans. So, for example, there was a pumping plan. There was a fire and rescue plan, which had all the hydrants recorded. There was the deputy's district plan, which zoned the mine into who had responsibility. Believe it or not, we had a fire damp drainage plan. So some of the workings encountered methane, and we had to drill boreholes above the seams as they were being worked to drain the methane. So this was all captured in a pump range and pumped to the surface, and just let out to the air. You know, nowadays it would be captured and used as a fuel. You know, I mean, the other thing to stress is people just wouldn't understand how complex and how vast a modern coal mine was. And for example, we were pumping at 4,000 gallons a minute of water at the last pit that I worked out. That's 300 litres a second. And we were pumping 4.5 tonnes of water for every tonne of coal we produce. And we were going further and further out under the sea. We were 9.2 kilometres offshore. It was just a huge enterprise, you know?
I mean, I can remember Westoak Colliery opened day, what was it, 1990, 1991, I can't remember what year it was, but obviously going down, and went down in the lift and to this, well, basically it was an access tunnel. Didn't really go past the work to that, but
no, it was shaft bottom.
Yeah, shaft bottom, and basically it was, you know, to describe it visually to something, it was like the Tyne Tunnel. In the fact, it was a roadway. It had, you know, it had infrastructure, had a railway. It had a train. There was what were called locomotives, right? Yeah, you know, and carriages, etc. But you know, how far out did we say? 9.2 kilometres that went out, and obviously as things were industrialised, those conveyance routes to the seam from a shaft get bigger. So what's happened? What would they, if we could send a camera down now, what would they look like now? If they've been grouted off?
Well, no, I would think the main arterial roadways that you referred to from the shaft bottom, the arch roadways, they'll be standing, pristine condition. I mean, they might be flooded with water, you know. But where the coal seams have actually been worked, the gouged areas, coal faces, they'll have been collapsed. And just as a general rule of thumb, when we were working out how much water would be held in the redundant mine workings, we used to always work on a figure of 15% of the extracted would be left as a void to be filled with water. But the main arterial roadways, the arches, they'll be standing like they were.
But just probably flooded.
Flooded.
No, and again, trying to understand that, you know, from what I'd seen from an industrialised mine, you know, a modern mine, compared to say what was around Kibblesworth or Marley Hill or Chopwell or somewhere like that. You know, and again, my only other kind of comparisons, the drifted Beamish, which, you know,
totally different. Totally different.
So these conveyance routes between collieries and coal faces, how big were they then?
Well, they were 14 foot wide and 12 feet high, generally, arched roadways. But you mentioned the locomotives, and it had a track. Of course, it had a track, and those tracks were concreted in place, and the locomotives ran at 25 miles an hour. It was just like the London Underground.
You mentioned the London Underground there, and I've just got to get my little side fact in here that Kibblesworth was where they first tried the Underground Railway for the London Underground. Right, we'll move on now.
Fun fact.
Fun fact.
Well, we've had a great conversation so far, and I really want to just close it out with, if you could come up with one idea, one disruptive, transformative idea to completely change the landscape for the better with regards to groundwater flood risk in general, and obviously in particular the relationship with the mining legacy of the Northeast. Rhiannon, what would that be?
Well, that's a good question, because I think it's a lot of what we've discussed, to be honest. I think if you decarbonised the heat network and changed that would be massively disruptive and change it all. Because obviously, from a decarbonisation perspective, if we're able to deal from flood risk and the impacts that has on local authorities, and obviously working with Northumbrian Water because of the potential for interactions with their network, that had changed so much across different industries and industries that we don't even kind of think of as related.
Yeah.
I think that's the key one, that would change an awful, maybe very quickly, it's kind of a bit generous, but if you did start to roll that out, it would have dramatic, probably quite global changes where people would pick that up and change it.
I don't think we understand the potential as a region.
Just on a regional scale, never mind. It'll be picked up. Already there's interest globally in kind of what's done at Gateshead Council with the mine heat scheme. So
because I know Dad's done some information sharing with Coal Authority on trying to kind of get that information out and about. But I think, you know, for me, I think kind of when I've been looking at solutions of this prior to this project, you know, I was working with Jeff Parkin at the time at the university, and he was, you know, we were looking at potential options of, say, something like a gravity discharge. But then now there's that feasibility of district energy and mine water heat. What you don't want to do is reduce the flood risk, but then stop an opportunity of using district energy.
I think this is where, and I guess this comes into the innovation and how our project, even though it's within the groundwater network, how it differs from the other groundwater projects, where because of the mining legacy, if you were looking at something like a gravity discharge, that's a very localized solution, and there are so many, and the amount of water that would need managing, that you need to look at it on a regional scale. And then we can, I guess, if we can start to think of the regional scales and dealing with it at the source, then we can isolate where may need engineered solutions at surface. I'll just add, I think the benefit, and it's been touched on quite a lot, but the benefit we have in this particular area, kind of around the Durham coalfield, is that the plans tend to be quite good.
See, it's just testament to good work there.
The plans are good and relatively recent. So that's where, when we look at the other study area in Berwick, because the plans are so old, that this is where we're kind of have to investigate and conceptualize and understand the influence of those workings a lot more, because the information's not there.
I'm going to pull Paul in because there's whiplash going on here.
You haven't given us very long to think about that interesting question you posed there. But I always tell people, when I started my apprenticeship in 1970, coal was the fuel of the future. And you know, despite all the bad press it has, I still think it's potentially got a role to play in the decades ahead. It may well be the old mine workings could be used for carbon capture in the future. The other thing as well, I think, I don't know that we've exploited the geothermal gradient. The way, I mean, again, I know from your own experience, the deeper we went, the hotter it was.
I think, Paul, you've taken us through the kind of intelligence that most people are not aware of, because the information is there, but do people know where to go looking for it? And it's actually quite good to talk to someone like you, because you're like, do you know about this? And you're like, oh, right, okay. You can ask the right questions. You can ask better questions as well, because it could all be there, but if you're not asking the right questions, you don't get to see the information you're looking for. So very, very grateful for your time today. We're around for a few more years, so this particular conversation will continue for a while yet as the project evolves. So thank you. And thanks to Rhiannon for joining us.
You're welcome.
Thank you.
Cheers. Thank you, everyone. Thanks for listening to the PGN podcast today. We hope you found it informative and enjoyable. If you did, please like and subscribe to the podcast. But also, please, if you find this useful to anyone else, pass it on and spread the word.
To find out more about Project Groundwater Northumbria, please visit www.pgn.org.uk.